Okay, I think that's got it. Welcome back, everyone. As promised, we are going to roll straight into testing and troubleshooting. So, let's write a test case. You know what? Let's actually start with smashing our two pieces together. For we have, there's test heap, and there's heap ops, and there is enforce heap. So, let's write another function. Int HeapSort. Whoa, we're cruising now. Tell you what, I think we'll do unsigned int star h. And does it just need end? I think it just needs end. And I can always come back and fix it later. Return 0 if you work. Alright, so the first thing we are going to do is enforce heap. I think that's what we called it, right? Yes, enforce heap. Oop, went a little bit too far. We will enforce the heap of h and end. And then, because we didn't build this in, we very much need to swap. We could have put it in heap ops. It doesn't really matter where you put this. Oh my, excuse me. Swap h sub 0 and h sub end minus 1. That's how we get that large number at the end of our array. And we will heap ops h comma end, and that has the swaps built into it, so that should be the only thing we need to do. Cool. Alright. Unsigned int star test sort. And this is going to need an unsigned int tests and unsigned int end. Very important. And I think we can just go ahead and copy and paste a bunch of this business. Actually, I think we can go ahead and copy and paste most of this. Oh, shite. What did I just do? Okay. We're going to use the in-nano copy and paste dealy bopper instead of the GUI copy and paste dealy bopper. Don't worry about what that means. I grabbed the wrong part. Oh well. Cool. Free heap. And I think the only thing I had left was return 0. Cool. Alright, slight difference here. We're not going to enforce heap, we are going to heap sort. And this logic needs to be a little different. This is gonna go to end minus 1. And J++ is gonna be fine. If heap j is greater than heap j plus 1, then we're going to return heap. Otherwise, we're going to free heap. Okay, that looks like that might just work. Alright. Test sort. Make sure we got that spelled right. Got a bunch of funny business up in here. Okay. Cool. Nano heap heapsort. Yeah, that's what we want. And that was on line 86, or it was pretty close to it. Unsigned int. Unsigned int. There we go. Much better. Oh, probably need an N over there too. Hey, there we go. All right. Moment of truth, ladies and gentlemen. Oh, failed instantly. Okay. So, that means we have an error in our logic. I wonder what it could be. What are we doing on time? 5 minutes. Good. We got a lot of time to sort this out. I suppose we should, just as an insurance policy, throw a j equals end down in here. And j is supposed to be less than or equal to the last non-leaf node. Okay. Doop-a-doop-a-doo. How do we want to go about getting our printfs down in here? It's not throwing seg faults, so that's good. Doop-a-doo-doo. Doop-a-doo-doo. Looks like we get LGN and RGN established correctly. Sure seems that way. Did we swap them correctly? Ha! Yeah, you can't do that, can you? That's got to go up there. Yeah, there we go. Swap H of J and HP of J. There we go. Maybe that'll work. Oh my, okay. Ho ho. Thought I was somewhere I wasn't. Do, 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 do. H of J and H of P of J. That might do the trick. Nope. Fails right at 0. Ah, is this doing the thing where it swaps? I think this is doing the thing where it swaps the last node with itself, because that will produce a 0.
That's why I'm president of the Fashion Club.
Hey, there goes my phone. I hope you all enjoy my ringtone as much as I do. We're going to need to get that ironed out either way. Aha, yes, end -1. Ah, typing's hard. Okay, now at the very least, it shouldn't be pulling a 0 out of freaking nowhere. Yeah, alright, so we still got issues. So one thing we can do is we can go back and try to prove to ourselves that our enforce heap function does in fact work by... Oh, come on, where's main? if heap test heap. We did verify this yesterday, but never hurts to double check. Okay, cool. So as long as our test is accurate, that means that should be working. All right. How do we want to go about doing this? I really didn't have anything that did that. Okay. Fair enough. Okay. We do have to get some information coming out of here. How do we want to do that? Oh. N needs to be n minus I, because we are actually shrinking our data structure each time. Remember to do it down here. Alright, fair enough. Give her another crack. I think I actually forgot to... Yeah, gotta test the sort. Otherwise, garbage in, garbage out. No. There we go. Okay, it is still failing. Why is it still failing? Well, we can always just print the heap in here. For j equals 0, j is less than n minus I, j plus plus, printf, unsigned integers everywhere. That's not a problem, is it? No, I don't think that's a problem right now. Percent %u, and then that is going to be j and heap h sub j. Oh, gotta make a new line. It's got some reason not to. You always want to remember to include that new line. Printf. Printf. Colon percent %u. Percent %u. L. Percent %u. R equals percent %u. New line. And we are going to want j, and then we are going to want h sub j, h sub L of j. We're doing on time. Ooh, rolling right up on it. Okay. Well, Maybe we'll make this one 2 videos. R of J. I believe that's all we need. You know what? That should do the trick. Alright, let's see what we get out of that. Oh my. Well, that one's on me. Silly, silly. Oh, that's not right either. That should do the trick. Oh, okay. What do we got here? Alright, so the first one's going to swap left. That does seem to be the correct option. And that's the end of it? That should not be the end of it. Okay, that's very interesting. We are updating J incorrectly, it looks like. We're definitely updating J incorrectly. How did we get that 5,000 number all the way up there? That doesn't seem right. And what replaced it? Get used to this, folks. You do a lot of this when you program. Okay, so J's supposed to be the left child of J. So if it swaps, we're almost guaranteed. Oh, right. Curses. Okay, I thought I was being slick there. Ha. You can put continue statements in each of these. I guess we don't need that. It doesn't need to be end if we're breaking. Okay. Well, you do silly things when you program sometimes. You're a human being and you're guaranteed to have a lapse of attention. And the only way to get better at paying attention is to force yourself to go back and look over your own work. Wow, that... Good golly. Oh, ha ha ha. We ran 50 trials, didn't we? That's why that's taking forever. Okay. So I think we may have actually just fixed that. Since it's not telling us we didn't, it should be fine. We don't want GCC, we want nano. I'm going to go ahead. Get rid of our internal printfs. It is somewhat unprofessional looking. Don't need that. I had a decent way to update those. How are we doing on time? Okay, we just hit the 20-minute mark, so if we're good, we're good. Yep, we got rid of all... I think that was all the internal ones. Did we screw anything up? Let's find out. Okay, so it looks like our test here is reporting that we're good. And the last thing you want to do is look inside it yourself. Just to verify. Why am I going down one line at a time? They give you a page down button for a reason, folks. We can go ahead and comment that out. And I think what we're going to do is just to prove to ourselves that this is in fact sorting correctly for I equals 0, I is less than end, I plus plus. Ooh, made that mistake more than once today. Heap I equals rand, srand, time, null, heap sort, heap end, for I equals 0, I is less than n, oopsie, end, I plus plus, printf, heap, %u, equals %u, new line, and then we're going to want I and heap sub I. Doesn't help anybody to say it wrong. That should do the trick. 1, 2, 3, 1, 2, whoa, ho, ho. And if I hit end, no, it just takes me to the end of the line. Curses! That's okay. Heap sort right there. Do. And we'll set that out. Segmentation fault! Alright. What on earth did I do wrong? Something very silly, I'm sure. Oh, come on. Let me just get this printed out. We're not even going to cram this all into one function today. How are we doing on time? Ooh. We are over. I is less than end. Aha! That was the issue. Oh my lord, you are kidding. Unsigned int from int makes pointer without cast. Isn't heap? Oh! Hardy har har. Pointers. Keep track of whether they're pointers or regular pointers. Alright. Hey, there we go. Now we're cooking with gas. There! Okay, that took way longer than it should have. We're rolling up on 25 minutes, a lot longer than I like to go. But you can see that our heap sort algorithm did, in fact, sort the heap. Hurrah! I think if I was going to write this, well, I wouldn't write this in real life. I would use somebody else's, but it's instructive to do it. That said, if I was in a situation where I had to write this, some kind of microcontroller or something, I can imagine, I would probably cram these both into the same function. Something, the machine stack, something uses extra memory if you have them in separate functions. So I take these, cram these all into the function HeapSort. That said, we are over 25 minutes. We're going to call it there. Thanks for watching, everybody. I hope you learned something, and have a fantastic day.